In this video, we're going to discuss why the sine angle addition formula is true. So start with this side that's drawn right here, and we're going to draw in an angle u, and then on top of this angle, we're going to draw in some other angle v. Now in the picture, it looks like these two angles, u and v, they're about the same size. They don't need to be the same size, but you know, just pick something to work with. Now we're going to draw in right here from this point. Just drop a perpendicular right there, make this 90-degree angle. And we're just going to choose this side length to be 1. This is really the only side we'll choose. You don't have to choose 1, but using a 1 will make the math work out a little bit nicer. And we'll unhighlight that part red, and then drop this down here. There's going to be a right angle right here. And actually, where this intersection is, drop another line. So these two lines are parallel. We'll draw in one more thing, which is this horizontal side right here. So what you can see actually in this picture, there's actually a rectangle right here, and we're going to refer to some pieces of this rectangle in just a second. Now what I'd like to do is just highlight this triangle, and we're going to talk about, take the angle v inside this right triangle, and we have this hypotenuse side that's 1. I'd like to label these two other sides A and B, and actually if you just write out by definition of sine, you have the sine of this angle v is going to be opposite, which is A divided by 1, and you could solve for A there and get A is equal to sine of v. Likewise, you can set up cosine of v as B over 1 and solve, and you have B is equal to cosine of v. So let's take these. We labeled A and B, but introducing these new variables A and B was actually a little excessive, and we can just kind of make these replacements, and we'll have this side was sine of v and this side is cosine of v. And now what I'm going to do is actually look at this other right triangle here. Now this side, this length that we know is cosine of v, actually ends up becoming the hypotenuse of this other right triangle. And let's label this side right here P. And actually, if you use the definition of sine again, but now for angle u in this right triangle, well, sine of u is opposite, okay, P divided by the hypotenuse, which is cosine of v. You can solve for P right here, just multiply by cosine of v on both sides. So P is equal to sine of u times cosine of v. We're going to need that a little bit later, so I saved this over here. And actually, we don't actually need this triangle anymore, so labeled this side length, which we just found. This is that same thing. So P is this side length right here, and we actually don't need that side length anymore, so I erase that, and you can actually copy this P. That's over here. This is just the other side of a rectangle after all. Now take a look at this angle U, and due to the parallel lines right here made by this rectangle, this angle, this interior angle, appears right there again, and actually due to this right angle, the complement of this blue angle, so this angle U, actually shows up. Here's the complement of that angle. And then now take a look at this right triangle. Well, you have a 90-degree angle, this complement of the blue angle, and so you actually have the blue angle here again. So if you add up these three angles, you have to get 180 degrees. So this angle up here is actually the same size as the angle U that's right there. So we just labeled that U, and I think we're now just going to get rid of all of these other labels. We're not going to need them after all. And now there's one other little right triangle that's right here. There's a right angle right there. And what I'd like to do is actually look at this mystery side Q inside this right triangle. And so for angle U, you have the adjacent side, you have the hypotenuse side. That calls for cosine. So cosine of U is Q, the adjacent side, divided by sine of V, the hypotenuse side. Solve for Q here by multiplying by sine of v on both sides, and you have q is equal to cosine of u times sine of v. We're going to need that again, so I saved this over here. We're not going to need anything else. If I step back one spot, we have this q. I'm just going to label the q on the other side because this is visually distracting. Get rid of this sine of v, get rid of even this blue triangle, get rid of this p side. All we have here are these two lengths, and this lower length here in gold is p, and then this upper half right here, this upper piece right there is Q. And actually there's one other right triangle in this picture that I'd like to look at. And in this right triangle, actually you have this angle over here. This is angle U plus angle V. So you can set up sine of U plus V, and this is the opposite side, which is P plus Q, okay, divided by the hypotenuse side. That's 1. This is the first time we're using this one actually. But we actually know what P and Q are, so you could don't even write the divide by 1, but sine of U plus B is now, well, it's P, or sine of U times cosine of V, plus q, which was cosine of u times sine of v. And so there's the sine angle addition formula. Sine of u plus v, that's this. And then replace the p with sine u cosine v right there. And then copy the plus sign that's right here. And then q, so replace right over here. And you have cosine of u times sine of v.